Welcome to Altaform, a PHP framework for yesterday and tomorrow. But what does that mean? Let's start with what some of the goals are for the Altaform framework. Well, for yesterday, we have backwards compatibility. For tomorrow, we have forwards compatibility. The Altaform framework will work on PHP 5.4, but it will also work on modern versions of PHP such as 8.1 or even the current in development 9.0. Why do I support such old versions of PHP? There's many old legacy systems out in the wild today. Many of them are running PHP 5.x. Many of the modules within Altaform can be broken out and used individually separate from Altaform itself. By converting a legacy code base one piece at a time, it allows developers to modernize their code base without rewriting the entire code base all in one go. For instance, you can convert database calls over to what Altaform uses without using the rest of the framework, updating your existing code one piece at a time, and then when you're ready, make the jump to the final version. Once that is done, you can upgrade your servers from legacy PHP versions to modern PHP versions. As you're about to see, Altaform is a zero boilerplate framework. This is one of the core ideals of the Altaform framework. Think about the amount of time you have to define a class, or define a model in an ORM, or define a route within a URL router. With Altaform, you don't have to do any of these things. You focus all of your time on writing business logic, never having to worry about fighting with the framework itself. This is all handled through a simplified architecture. At the core, Altaform is a thin layer on top of PHP, rather than trying to redefine what PHP was designed and meant to be. With this in mind, this reduces cognitive load. That means as a developer, you have to spend less mental energy trying to figure out what you want to do or trying to debug your application. You spend more time focusing on the business logic rather than the framework logic. As such, this directly leads into rapid web and API development. Unlike many other frameworks, Altaform is also built around a security first everywhere mindset. Security is not something that I bolted on at the end, it was something that I started from at the beginning. As such, the entire code base is very easily auditable. Rather than requiring complicated external tooling, you can simply look at a single file and know exactly who and what can interact with that file. Let's start by going over the features of Altaform one by one and showing how they work. The first feature I'm going to cover is the Altaform URL Router. Everything is an island. Unlike other routers, there is no route file to manage, so in this regard, there is nothing to show you. Do you remember the old days of the LAMP stack, where you had Linux, Apache, MySQL, and PHP working all together in unison? You'd put a PHP file in your web root, and that file became the URL that you'd access in your web browser. This was a direct one-to-one mapping from the URL to the path on your file system. Altaform recreates this level of simplicity. To show this in action, I'm going to create a new folder. I'm going to call this API. We now have a home for all of our APIs. And inside of our API, I'm going to go ahead and create a new file and call this time.php. Inside of here, I'm going to start a new PHP document. And I'm simply going to echo time and then save that file. Over here on our web browser, I'm going to go to API/time. And that now displays the current Unix timestamp. We've now just effectively created our own API. As you can see, there is a one-to-one mapping between this API/time and the API/time.php within our project. I'm now going to create a second file and call this one microtime.php. And I'm going to do the same thing. I'm going to start a PHP document and echo microtime. And now over here, if I go to microtime, we now have that. However, this is not the format that I want this to be in, because this is showing our decimal and our Unix timestamp as two separate items, and I want them combined into one. So I'll go back here and switch this to true, and then refresh. Just as quickly as we can create and save a document, the API is already available and already producing the results that we want. Altaform can also be used to create console applications. For this, we have the command called AF for Altaform, and then we can simply type in the path like we did up here. So I can go API time, or I can go API micro time. I can also use slashes, just like you would on the web. Either one of those will work, and then it outputs the corresponding text just like you would see in your web browser. This could be used for rapid prototyping, or this could also be used for creating a console administration interface for your web applications. As you can see, no additional code has been written for this to work. Simply creating a file on the file system ties all of this together automatically. Now let's go ahead and clean up this output a little bit, because when we're dealing with consoles, we probably want a new line character at the end. So I'm going to also say a new line at the end of there, and let's add a new line at the end of there. And just like before, that now works, and that now works. We now have a clean console output on both, and because the way web browsers work, there's no significant change on the web output. Unlike other frameworks, the Altaform URL Router does not use complicated regular expressions. However, it does retain virtual pathing support using another method. First, let's create a new file inside of our API folder. We will call this _virtual.php. Altaform has predefined special files. Each of these files are prefixed with an underscore and has a predefined name. The _virtual PHP file is used for our virtual routing system. Let's start out by defining our PHP header. And we are going to var export router arrow virtual. Let's save that and load that path in our web browser. API example. And we can see that we have an array of a single element with the word example, which is the first part of the path that does not match our file system. As you can see, the virtual pathing system is an array. And if we put in folder/file, you can see that become populated within our array when we load that page. If we return to our console, we'll see that this feature also works there as well. So if we go AF, API, example, test, 1, 2, 3, hit enter, we see the array populated with example test 1, 2, 3. The virtual pathing system also supports more complicated matches. Rather than simply matching the end of the path, we can also match the middle of the path. We'll do this by going to our API folder, creating a new folder underneath it called _virtual. Let's move our existing _virtual.php file inside of this new folder and instead call it _index.php. Much like a traditional LAMP stack, the index file will be loaded if there is a match on the folder but not anything within the folder. Now if we go to our browser, we can only match at one level deep. We now get a 404 message for this particular path. However, if we change it back to our example, it is now matching the virtual folder and then nothing inside of it. It is loading the _index.php file instead. So now let's create a new file inside of our _virtual folder. Let's call this test.php, add the PHP header, and then let's var dump our router arrow virtual and echo out, this is our test. That way we know it is a different file. Let's save that and then load that over here in our browser. And you can now see that this particular test is being loaded. So we are now matching on API, and then example is matching to virtual, and then test is matching back to the test.php file. Right now, Altaform is outputting this as if it was an HTML document, including headers and footers. But instead, to make this easier to read, let's output this as a text document instead. Let's go to the beginning of our code and add the line AF, arrow, content type, and then put txt inside of it. Let's save that and then refresh our browser, we can now see that it's being passed and processed as a text document rather than an HTML document. The Altaform router also supports internal virtual redirecting. So let's go back to our API folder, create a new file. Let's call this game.php. Let's start by creating our PHP header, have router arrow replace, and then inside of replace, let's add a new path forward to route to. It's going to be API time. Let's go to our browser and see what this looks like. Internally, the route array has been replaced with this new array and has been reprocessed, and has now loaded the time.php file. Let's change this to microtime, and you can see that it's now loading the microtime path instead. So now let's take a look at the database capabilities. Altaform uses the PHP Universal Database Library, otherwise known as PUDL. It is a SQL query generator. This library can be used independently of Altaform. You can find out more details over at pudl.dev. First and foremost, PUDL is not an ORM. You will not be defining your models within the code base. PUDL simply generates SQL queries and then executes them. PUDL assumes that the model definition is handled external to the application. The reason for this is that data sources often have more than one application interacting with them. Not every application will have control of the model. This puts the control of the model in the hands of the database administrator rather than the software engineers. This allows the database experts in the field to make informed decisions rather than having the software engineers make these decisions. As such, the first core principle of PUDL is that it can run raw, unmodified SQL queries. Let's see how this is done in action. Over in my APIs, I'm going to go create a new file. I'm going to call this states.php. Right now I have a SQLite database that Altaform is connecting to. Start by creating the PHP definition. We're going to create the states variable equals db, and then inside of this, I can execute whatever query I want. Select star from state. Now what I want to do is we need to output this information. So let's go Altaform. We're going to output this as a CSV and then our states value. And then we save this file. So now when I go to API/state, we now have a CSV file generated from our database. This also shows other functionality of Altaform. It has the capabilities of outputting different data types based on developer and API needs. Now that we see we can run our own SQL queries, let's have PUDL generate the query for us. So I'm going to create a new folder and call this state. Inside of state, I'm going to create a new file, my virtual.php. Give the PHP definition, and I'm going to go state equals db row, and then inside of this, I'm going to say which table I want to access, and then what data I want to pass into it. So we have the ID field that I want to pull from router virtual 0. So we know that entry 0 within our router virtual will be based on the URL. And what I want to do is AF JSON, our new state value. So let's save this. And if I go state, that does not work. If I go state WA, it now gives me a JSON output for Washington State. And I can go here and look at the raw data to see the exact JSON value that was returned. What happens if I go to state Bob? Right now it returns false. However, what if we want to have this return an error 404 message? We have not gotten into error handling yet, but let's try a little bit of that now. So I'm going to go AF affirm. 404 is going to be the error message that we produce if the data is not found. Let's tab this over. And so I've basically wrapped our database call inside of an AF affirm. Affirm just says, make sure this exists. It's similar to an assert, but we couldn't use that because it's a reserved keyword. So now, when I try to load up this, we now get an error 404 page. If I go back to Washington and refresh, that still works. Let's go back to our previous example of the states. We initially created our own SQL query. We can also change this to use the query generator instead. So if I simply say database rows for the state table, this will in effect do the exact same thing. So if I come back here and go to states, make sure that's refreshed, and it looks good. Puddle will also automatically escape identifiers and data. Puddle also offers an easy way to debug the queries that it generates automatically. So I'm going to take out the CSV for now, and instead I'm going to echo out db query. And this will show us exactly what the query is. So now if I come to our browser and refresh, we can see it generated select star from state. We can also see that for the identifier for the state table, it actually encased it in double quotes, which is what SQLite uses for identifiers. If we were using, for instance, MySQL or MariaDB, this would be encased in backticks. Now let's go back to our other example, and let's do the same here. We're going to go echo db query. And let's go back to state WA. And we can see here it did select star from state where ID equals WA limit 1. And it properly added quotes around WA, and it also properly added double quotes around both identifiers. Because row has the assumption that we're only pulling one row, it also added a limit 1 clause to this for us automatically. First, let's remove the check since we will be accessing invalid data. Next, let's try to add a quote to our URL and see what happens. It is properly doubled up. What if we start adding in other characters like // As you can see, Puddle handles all of this fine with proper escaping without injecting it directly into the database. Additionally, there's protections before we even get to this layer if we try to access really broken data, for instance, adding a null character into our URL encoding. This is all part of the security-first mindset. Puddle also has support for most major SQL databases. If we check out the puddle.dev website, we can see the list of supported databases. These include MySQL, MariaDB, Percona, each of the MySQL variants with Galera clustering. There is a null type database, which is a functionally dev null, Microsoft SQL Server, SQLite, any generic ODBC connection, Actian PSQL, PostgreSQL, PHP's built-in PDO driver, and then some custom interfaces for accessing SQL over a shell connection, HTTP connection, or cloning an existing interface internally. To use Puddle outside of Altaform, it is as simple as including the puddle.php file and then creating an instance as shown here. Much like the previous examples, inserting new data into the database is as simple as calling a db insert, telling it which table you want to insert into, and then use the key value pairs to show which column and value you want to insert. Updates are handled much the same way. However, you have two arrays. The first array contains the data that you want to update. The second array contains your where clause, similar to a select statement. With a select statement, if you call rows, you'll get a multi-dimensional array where the first dimension contains each row, and then the second dimension contains each column within the row. The rows function can also take an optional where clause like we've already shown before. Similarly, as already shown, there's also a singular row function that will add a limit 1 and return a single dimensional array as the result. When forming a where clause, you can put in more than one element into the array. This will generate AND conditions within the where clause. For where clauses, if you nest an array inside of another array, it will alternate back and forth between AND and OR conditionals. Next, let's talk about the getVar module. Get and post request data made easy. getVar is designed to read data without any boilerplate. Let's see how that works. First, I'm going to create a new file, country.php, and we're simply going to echo get code, and that will be our file. Let's go to our API, country, and so far there's no output because we haven't specified anything for code. So if I go here, code equals test, we now see test. getVar supports alternative syntaxes as well, so we can also use arrows to do the same thing. getVar also supports automatic data type conversions. Let's see this in practice. Instead of get code, there are some predefined things that get also has. Let's get an integer of code. That is now 0 because we're not passing in an integer, but if I pass in 15, we now have 15. If I do 15.9, it still treats it as an integer, and we still get 15. We can then change this to a float, and we now see our 15.9. For each of these functions, there is also a null variant. So if I specify null, let's do a var dump this time. We see that it is giving us a float. However, if I remove this parameter, it now returns as a null rather than a 0. If I remove the null at this point, and this value is not passed in, it will now be treated as a float 0. By default, Altaform will trim white space at the beginning and end of an input. And this becomes very handy because users oftentimes are copying and pasting data from one place to another. If they're copy pasting from a table within a web browser, they may copy over a tab character or an extra space character, for instance. We usually don't want those in our input. So let's go back to our original example. I'm going to go back to our API, country, code equals space, test space. And we can see that there is a space character up here. It does not pass through getVar. This is especially useful if you are taking in usernames or email addresses, as you don't want those additional space characters at the beginning or end. And this helps eliminate end user frustrations. This feature can also optionally be turned off. Some functions have it turned off by default. getVar also handles missing data safely. getVar also handles input sanitization. So we can use the filter function with our code and tell it filter sanitize email, for instance. And now when we go to our API, country, code equals, this is a test at example.com. Notice how it removes characters that are not part of the email. There's different filtering methods built into PHP that this will use. These filtering methods can either do input sanitization or input validation. There is also direct puddle integration, which automates part of these steps. What I'm going to do now is country equals db row ID from the country table, where ID is get. And then our var dump is going to be of the country variable. So now let's go to our API, go to country, ID equals US. And it is now pulling that information from the database. And just like before, we can also go AF JSON to output this. We now have an API where we can query a country code and get the name of that country. The way that the puddle integration works is that when you have a key value pair, this key is then appended to get automatically to pull the value out of get. This would be a function equivalent if we said get ID. You can find out more about getVar by visiting github.com/arcane/getvar to view the repository as well as basic documentation. So now let's talk about the Altaform security model a little bit. In Altaform, security is a core feature, not something that is bolted on at the end. Going over a quick overview of what we've already covered, the URL router rejects bad input from users. Looking back at the puddle library, it properly handles escaping data passed in by the user, preventing SQL injection attacks. I've also shown different ways that getVar can be used for input sanitization and validation, and how it can filter out potentially harmful inputs. For this next part, I'm going to show a live website and how its security model is implemented. There are multiple points to cover at the same time here. First, the inclusion of the _Altaform PHP file. Similar to a traditional LAMP stack, whenever Apache enters into a new folder, it will check for an existence of a .htaccess file and then process that file before proceeding loading content from that folder. Inside of Altaform, we do the same thing with the _altaform.php file. In this particular case, we want to restrict access to logged in users for this entire folder. Whenever the Altaform router enters the settings folder, it will first load the _altaform.php file and processes contents before attempting to load anything else. In this application's case, we want to restrict this entire folder to only users that are currently logged in. In this case, we have the user variable, arrow, and then say require login. That is the only thing we need to do to validate that a user is logged in. When we see this live in this particular application, that one line will take us directly to the user login screen, where a user can also create a new account or reset their password. All of this is being handled by that one simple function call. Similarly, there are other calls for different permission levels besides simply logged in or not. In this particular case, we want to check to see if a user has the staff permission or the system administrator permission. We can see this being applied to the admin folder, where it specifically tells us that the following permission is required, either staff or admin. This is accomplished similarly with the require staff function on the user object. Additionally, there are also object-based and role-based permissions. In this particular example, site staff or anybody with the event permission has the permissions to manage event objects. Now let's get into debugging. Once again, Altaform is a minimalist to the very end. Let's start with a call stack. Altaform uses a very shallow call stack before entering the main application. With its default configuration, Altaform will only have 3 items on the stack before entering the application, making debugging a lot easier. You don't have to sift through 10 to 20 call stack items of framework information before getting to your application, which is what matters to you the most. Additionally, Altaform tries to minimize use of global variables wherever possible, ensuring that you as a developer stay focused on your application rather than on the framework. This is a list of all the global variables within the current framework, including all that PHP provides itself. Altaform also includes a fully featured HTML templating framework, known as Tiny But Extreme. The Tiny But Extreme library is a fork of Tiny But Strong, an open source PHP templating library. This fork includes countless bug fixes as well as plenty of new features. All of the legacy code that is no longer used has been removed from the library. The performance of the library has also been greatly improved for faster page rendering times. I've also completed an extensive security audit of the code, fixing many of the insecurities of the previous library. Tiny But Extreme is also fully integrated into the complete Altaform framework. As you may notice, these slides are really just HTML files, and for this one, I'm showing the code on the right. The first thing is that there is a title tag. There is no header tag. The title tag is being pulled out of this document and being correctly put where it needs to be within the full HTML document. If we right-click on our web page and go to View Page Source, we can actually see that this is indeed a complete HTML document. The title tag has been brought up to the head, and then all of the rest of the content is brought down into the body. To show this even further, let's go over here into our app directory and look at our header page template file. I'm now going to create a new div. Let's add a style equals background light blue. This is now our header. If I save this, I've not touched this template at all. I have instead touched the header template. All pages will automatically inherit this template. To show this in action, let's go back to our database file that we showed before. This header is now also present in that document. And again, I can show on any of our other pages. This header is now present everywhere without modifying any of these other files. This templating framework is quite extensive and it supports many features. As you can see here, there is a variable being passed in, as well as a PHP function that is being processed on that data that is passed in. Part of the Altaform security model is that it does not use any package managers. There is no Composer, there is no PyPy, there are no node modules. Altaform entirely relies upon Git submodules. This has some disadvantages, but also some really good advantages. There are no command line tools to search for packages. However, you're not limited by any specific repository. Using Git submodules, you can pull packages from any Git repository anywhere in the world. This also alleviates supply chain attacks. By using Git submodules, you're tagged to a specific hash of a specific code base, rather than simply a name which could potentially be typo squatted or misconfigured. If an upstream repository becomes compromised, that won't affect your code as you're still tied to a specific commit hash from that repository before that action took place. Another advantage is from time to time, you may find bugs in upstream libraries. Using this method, since you already have a Git clone of their code base, you can modify it locally and then push those changes upstream, benefiting open source software everywhere. The Altaform framework is also highly performant. For a quick example, let's run a Apache benchmark against an instance of Altaform, using the API microtime that we just created, ensuring that each page, rather than being cached, we know is being generated uniquely every single time, passing through the entirety of the framework. We can see that this is running around 34 requests per second right now. That may not seem like a lot, but as you see on the right, this is actually running on the very first Raspberry Pi computer. 32-bit ARM 800 MHz CPU with only one CPU core. The computer you're using today is probably 100 times faster than that Raspberry Pi. So imagine getting over 3,000 requests per second on a modest performance server. To demonstrate that level of performance, let's actually try this on my Xeon Gold server. We can see we are getting well over 4,000 requests per second on a single box. And again, this is all without any page caching. This is processing the entirety of the framework on every single request. To wrap things up, this has just been a quick cursory look at some of the features of Altaform. There are countless more, and each of the features shown today can easily be a multi-hour talk as well. Some of the key highlights, however, the zero boilerplate framework and the simplified architecture. If you noticed, we never included any dependencies. Each time we created a file, we got right to the end result of what we wanted to do. Looking at the HTML templates, we're not worried about headers, footers, or anything else like that, as that is all automatically handled for us. The call stack and amount of global variables produced by Altaform is very minimal. All of this results in a reduced cognitive load on the developer. By keeping the mental state of the developer focused on business logic, it measurably results in reduced time to solving problems and fixing bugs within the code base. And by doing this, it reduces the amount of mental stress that each of the developer is on when working on critical parts of the system. This reduced stress means less chances of migraines and better overall mental health for the developers. And with a simplified architecture, as you've seen, we can rapidly build web pages and APIs. And every single component is built around security first, protecting the data and ensuring that malicious users cannot harm the system. If you'd like to use Altaform yourself, visit github.com/arcane/Altaform. The Altaform project is fully open source under the BSD 2-clause simplified license, allowing you to use this in your personal projects or any commercial software you would like to build with it.